Okay, on to graphing inequalities. So as a quick reminder, with graphing an inequality, we've got to pay attention to the line type. I mean, I should really be calling that like the boundary. And then the shaded region. So if we see an equal to sign, so like a less than or equal to or greater than or equal to, then that means we have closed dots, so that will create a solid line. If we see strictly less than or strictly greater than, that's open dots, so we'll see a dashed line. So those dashes are kind of a way of saying like there's not actually a point here. It's just that if there were actually a closed dot point, this is where it would be. So it's kind of like a force field. Like it's there, but you just can't like fill it in. Like it's not, you can't touch it. So the shaded region, if you see y is greater than or equal to, you'll be shading above the boundary. So if it was like this, you'd shade up here. If it were like this, you'd shade up here. And then y is less than or equal to, you're gonna shade below the boundary. If it's like this, you're shading down here. If it's like this, you're shading down here. Okay, so let's see. For number one, graph the inequality and then shade the region that represents the solution to the inequality. Y is less than or equal to -1/6 x minus 4. Okay, already I know that I am going to have a solid line because of that equal to, and then I will be shading below the boundary because I am less than. I'll say shade below. Okay, so now let's go ahead and graph our line. First thing, if you're on Eduphoria and you're doing this on Eduphoria, first thing you'll do is go to line A and select the line type. So here, it's automatically selected solid for us. So let's see, we're gonna start at the y-intercept, which is -4. So I'm starting here at -4 with a closed dot, so I'm equal to. And then to find my next point, I've got to use my slope, which is -1/6. So my rise, I'll treat this as like a -1 over a +6. I'm going to go down 1 and then right 6. So let's see, down 1, right 6. My next point will be right here. And it will automatically connect those points for you. Oops. Let me just make this look nice. There we go, sort of. There we go. Okay, solid line. Solid line. Okay. And we're not done because not only are we equal to those points, we're also less than those points. So on Eduphoria, you will tap or click this button, and then you will hover your mouse over the side that you want to shade, which in this case will be the shade below. So you will click somewhere down here and it will shade that in for you. So that is how you do number one. Now number two, there's two ways to approach this. Which ordered pair is in the solution set of y is greater than or equal to 1/2 x minus 2? Okay, one way is to use the graph to your advantage. So let's see. I know I'm going to have solid line because of the equal to. I'm going to shade above the boundary because of the greater than. So I'm going to start at -2, which is down here. And my rise over run is 1/2. So I'm going up 1, right 2, because I'm both positive. So up 1, right 2, boom, there I am. And if I'm doing this on paper on the graph, I'm going to keep going forever, like until I run out of pretty points. So I'm going here, I'm going here, going here, here, whoops. Then I'm going to go back to the original and go the other way. So down 1, back 2, down 1, back 2, down 1, back 2. And there we go, out of room. So now I'm going to connect my points with a solid line. Oops. There we go. Okay, then I'm going to shade above that boundary, so this way up here. So my solution region is on the line and above the line. Okay, oh, I should have picked a bigger highlighter tool. Okay, anything in there will be a solution. So let's test out our points. We got 8, 1. Ooh, that's actually my birthday, August 1st. How funny. Okay, so 8 comma 1 is right here. No, that is not in the shaded region. It is not a solution. No. Negative 4 comma 3. Negative 4 comma 3 is right here. Ooh, looking pretty good. Negative 2 comma negative 8 is down here. Nope. And then 4 comma negative 3 is down here. Nope. It's got to be B. Okay, the other way to think about this is a solution is a value or values that make a statement, that's right, true, true. Okay, so our statement is that the y value has to be greater than or equal to half of the x value minus 2. So I've got a whole bunch of xy pairs here. I'm going to erase my lines. So here, let's test out the first one. My x is 8, my y is 1. So is 1 greater than or equal to half of 8 minus 2? Let's find out. Half of 8 is 4, minus 2 is 2. Is 1 greater than or equal to 2? No, it is not. This is false. 1 is not greater than or equal to 2. Can't be A. Then you could keep repeating that over and over, like with each of these xy pairs. Only one of these will have a true statement. We'll go ahead and do part B. So let's see, y equal to half of x minus 2. Here the y value is 3. So 3 should be greater than or equal to half of negative 4 minus 2. So half of negative 4 is negative 2. Negative 2 minus 2 is negative 4. So is 3 greater than or equal to negative 4? Yes, it is true. So this ordered pair does make our statement true. Okay, let's see. Oh, that does conclude our section on linear inequalities. Let's see.